Section 2.4, Properties of Quadratic Functions, Part 3. Let's take a look at the general form of a quadratic function. Now, in the last part, we saw the standard form, which was really nice because we can see the vertex right away in the axis of symmetry. In the general form, we can't see it right away, but lucky for us, we do have a formula for the vertex. And the formula is, and I'm going to write this on the side just so you know, that x equals negative b over 2a. Now, because that formula only gives us the x value of the vertex, in order to find the y value, we do have to plug it back into our function, and then we'll get the y value. So let's go ahead and graph this in example 3, this function, and we're going to actually use the formula for vertex since we don't have our quadratic function in standard form. So first thing we want to do is find the vertex. And again, the x value for the vertex is negative b over 2a. So in this case, our b is 4 and our a is negative 1. And if we simplify that, we get negative 4 over negative 2, which is equal to 2. But this is only the x value. I still have to find the y value. So to find the y value, we simply plug in our x value into our equation. Okay, and if you simplify that, you should get 1. Therefore, the vertex is our x value, which is 2, and our y value, which is 1. And I'm going to box that. I like to box all the things that I find so that when I graph, they're easy to find. Okay, second thing, just like before, we're now going to look for the axis of symmetry. And once you have the vertex, this is fairly easy. And again, it's the equation of a line that goes right through my vertex. And it's a vertical line. Next, we are going to find whether the parabola opens up or down. Parabola opens. Okay. Now, notice this time that our leading coefficient, or the coefficient in front of the x squared term, is negative. So because it is negative, our parabola will open down. Okay. And then lastly, we're going to find our intercepts. X-intercept, set y equal to 0. So we have 0 equals negative x squared plus 4x minus 3. I don't like the fact that the x squared is negative. So what I'm going to do is I'm actually going to move everything to the left side. So I'm going to add x squared, subtract 4x, and add 3. That way I now have everything on the left side. And then the nice thing about this one is that this one does factor, so we're going to just go ahead and factor that. Okay, so we get x equals 1 and x equals 3. So we have two intercepts, 1, 0 and 3, 0. And again, I'm going to box that. And I'm running into my graph here, so I'm just going to move it over to the side. Okay. Lastly, we're going to look at the y-intercepts, and we just said x equal to 0. So we get y equals negative 3, and we have the point 0, negative 3 for my y-intercept. Okay, now we're ready to graph, and make sure you use everything that you boxed. So we have 2, 1. Okay, that's my vertex. 2, 1. And then again, the axis of symmetry helps us see where the graph is symmetric. Okay, that's x equals 2. We know the parabola opens down and we have x-intercepts at 1, 0, at 3, 0, and then y-intercept at 0, -3. And we're ready to graph. And then again, because this is symmetric, notice that there's 2 units from the y-intercept to the axis of symmetry. So there's also 2 units on the other side. So I'm going to go ahead and put a point there. And that's what my parabola looks like. Now, example 4 is a little bit tricky because other than the, let me see, where is it at? It's here. Let's go back to right here. This is where I'm looking at. The general form of a quadratic function is ax squared plus bx plus c, and we can find the vertex using our formula x equals negative b over 2a. But in this case, in example 4, they actually want us to use the standard form of a parabola. In case you don't remember, let's go back and look at that. It's right here. That's the standard form of a parabola. So how do we get it to look like that? Does it look familiar? It kind of looks like when we completed the square. So we're going to have to complete the square on this quadratic function. Let's go ahead and do that now. So we're going to complete the square. And this is simply to write it in standard form, to write our quadratic function in standard form. Okay, so we have y equals x squared minus 8x plus 21. Okay, and then we have y equals, and I'm going to zoom in a little bit so you could see better, x squared. Now, if you remember when we completed the square, we had to move the last term to the other side, but we don't have another side, so we're just going to keep everything here. Okay, so I have to add something here, but because we only have one side, I also have to subtract it. So whatever I add, I also subtract, because if I'm adding 3 and subtracting 3, I'm really just adding 0. Now, the reason we add and subtract is because we don't have another side. Before we had an equation, so whatever we added to one side, we added to the other. And in this case, we don't have another side, so we're staying in the same place. Now, if you remember from my last video, the way you complete the square, you take that middle term, the 8, you divide it by 2, and you square it. And whatever you did to one side, we did to the other. But again, we don't have another side. So since we're adding 8 over 2 squared, we better also subtract it. Otherwise, we're going to change our quadratic function. And we need to keep it the same. So we're just adding 0, really. Okay, and so I'm going to simplify that a little. And I say a little because I told you last time that I don't like to simplify that number, because this part here, we're going to have to factor and make it a perfect square. And it's easy for me to see what it factors out to if I leave the 4 as 4 squared. Okay, so first times first is x times x, and then outer times outer has to give me 4 squared, so that's 4 and 4. And it also has to add up to give me 8. In this case, -8. And I said last time, the signs have to be the same. So they're both positive or both negative. In this case, they're both negative because -4 and -4 give me -8. And that's what I want. Okay. So now I'm going to go ahead and simplify 4 squared. And we're going to rewrite this as x minus 4 squared. And then we have 21 minus 16, which is 5. And there you have it. You have your quadratic function in standard form. And they don't ask us to graph for this one, but if we had to graph, we know what it looks like. This graph, you can either use transformations. This graph shifts 4 units to the right and 5 units up, or since we are doing section 2.4 using vertex and axes of symmetry, we would say, so just for fun, they didn't ask for this, but we would say the vertex is 4, -5. 4, +5. Sorry about that. I just like to do deliberate mistakes. Make sure you're paying attention. And then the axes of symmetry would be x equals 4. And this parabola opens up since we do have a positive one. I'm not going to graph it. Hopefully you know how to graph and feel comfortable graphing these already.